we have been seeing the implementation of Bash, born again shell, directly as a powerful tool, directly operate or directly communicate with the operating system, okay? With the Linux operating system. We have been seeing command line that are directly in the Bash environment, like sort, like grep, okay? Or grep, we have been seeing head and tail for checking, and more and less for reading text file. Okay, so every time now that you having a text file, please start to use it, this command. Don't open with a graphical user interface. Then what else? Then we have been seeing the use of AWK as a string, as a text manipulator, especially when we want to work through the columns. Just to repeat, the AWK is doing whatever you can do it with Excel, let's say. Well, let's summarize. So operation between column, query, and so it's always starting with the AWK, and then you have the syntax, okay? The typical syntax, this one, okay? And you have an action over here that can be print $1, okay? Print $1, print $2, and $1 identify the column, but remember there is a dollar because each time, due to the AWK is going cascade, the value of $1 is the first time for row column 1, then row 2 column 2, and so on. So it's going, he has an internal loop to go down, okay? Then there are some other situations that where you have to operate through the column, that you have a for loop to move through the column. Anyway, usually with this and some if condition is whatever you need to squeeze in the data, okay? So this is what usually is done, is using AWK. Okay. Have you tried already to work with your data? Anyone want to sharing some doubts, or maybe tell the story about how he was trying to use AWK or Bash in his, with his data procedure and so on? Anyone want to share? Sebastian, you were trying already. Sebastian Munoz, you were trying already.
I had a question actually. That's perfect.
Oh, go ahead. Go ahead.
So I was wondering, just working with data, how you can, because often you have all your files in one directory, or all your documents in one directory, and if you want to make something new, how can you write those to a different directory so that they don't all get cluttered in the same directory? So you have one directory with all of your input files and one directory with all your output files.
Okay, so for just for simplicity, when we teach, we used to, you know, so if you have in the exercise and you are in the txt file, okay, we always try to enter inside the directory, okay, and over here we try to operate, for example, with this one, and you say, okay, AWK do something. Okay, do something here to this file. Okay, just print, I don't know, print $1, print $1. Okay, so this is, and you are going to produce one file, print $1, that is going to be just your latitude. Okay, just your X. Okay, so so this one is the typical example that we do it for teaching. Okay, but in reality, when you really work with your scripting procedure, you don't really enter in the directory every time. Okay, so you stay in the beginning of your folder. So let's say that I am over here and I'm working in the txt file. Let me change, first of all, let me change the directory, because as you see, if I'm working over here, I can destroyed, let's say, or make some conflict in my Git, and then I cannot pull it. So first of all, let's pull it all together. So if this is something that you have to do every time, we say git pull. So it's going to pull new data. Then you do the rsync, okay? And again, what I'm doing to recover the data, I'm doing Control R, and then I write R, Y, S, Y, and I get rsync. And then I can enter. Okay, so this one is making me the copy, and now I can go back to the SE data to keep talking about your problem, Sebastian. Okay, so here we were operating inside to the TXT file. So quite often what you do, you write, for example, you wrote make dir, you create two directory, input, okay, input and output, where you have your directory. So you can see over here, I have my output and input, okay? And every time that, now let's put the X and Y in the input directory, like if we are faking that we are working, we are having, no faking, that we have this one as an input, okay? So now my is inside the input, I have the X and Y. Okay, so now I want to operate with the AWK. So now again, Control R, AWK, I have already, okay, I don't have any more that line, but I can type in this case. AWK, I was doing something really, okay, print $1. So how I'm going to do it, I'm going to do input is going to be my input folder, and here I have my X and Y, and I'm going to save it in my output x.txt. Okay, so as you can see, I'm giving the path to my input and to the path to my output. Okay, so I don't really enter in the directory, but I work to one level up or more level up, and then I created. So something that I create a file where I want. Something that you have to consider is extremely important to have a very well organization of your file, because with these techniques you can create thousands of files, you know, or billion, like Aphrodite was doing, and then you can create some problem, you know. So it's very good that you organize very your file. And now I call it input, you know, input and output, but of course you can, you know, you can create the output for the X, where you are storing or the latitude information, and then output Y, where you store all the longitude information, for example. So try to always to create the subdirectory under your project, and working in this way, one level. And of course, now I'm just one level up, but you can go even more one level up, you know? Okay, so you can do perfect the same, but you do exercise input txt, and here exercise output txt. Okay, so you can work in one level up. Okay. Okay. Sebastian, is clear? Any other suggestion for this? Any other input, or anyone want to say something also in this direction of file organization? And, you know, this is file management in general. Good question. Anyone else? Some other question? Miriam, any question from you?
No.
No? Okay. Something also that that is very important, due to that now we are inside to the bash procedure. Something also that, as I mentioned a few times, we Longzhu, and we are not really using Jupyter Notebook or Jupyter Lab for the daily activity. because especially if you are working to the inside a cluster, you need sending job. So you need to create just a text environment, a software that use just a text environment to be able to send the scripting procedures to the cluster, to the cluster and to the queuing system. So you can use different editor such as gedit. Maybe gedit is not installed. I don't remember, but you can install it. Or Longzhu and I, okay, the programmer, let's say the old programmer, let's say the one born before 2000, they are divided in two: the one that use Emacs and the one that use VI. Okay, this is the big difference. Big difference, but it's a sort of so Longzhu AI, and we are using Emacs as an editor. That is this one. So you can create your script .sh. So sh stands for bash. Okay, is the name of bash. So I can put the end in this way. It's going to the percentage. It's going to the background. Sorry. So over here you can have this image. That this one is the welcome message you can read. I can do dismiss the startup screen. Okay, and this one is where I code. You know, I do cd/home user home. Actually, like I mentioned to you, we don't really enter in the directory, but we create variables. So in our case, we create input is going to be equal to my directory, this one, input. Okay, so now I do print working directory. Okay, so it's going to be this and this. Okay, so this is going to be my input folder. This is going to be my output folder. And here I can use the same, we use Emacs because we can use the same shortcuts that they are in the bash terminal. So for example, now I was fast, but I was doing, output. So I was over here, coming here, do Control K, copy, Control paste. I paste all the line, and then I come here, I paste again all the line, and I write output. Okay, so now what I'm going to do it in my scripting procedure, I'm going just to take this one, so take this line that I tested again, that I tested in the terminal. Okay, now is already copied. Sometimes it doesn't work, but anyway, if you do shift insert, let's see, and then the central of the mouse, just the center, is going to copy the full line. Okay, output, input. Okay, so this one now, they are folder. Sorry, folder. There are variables, so I can use output to store all information about the path. Okay, this is how we work. Okay, so the Jupyter Notebook is very good for get familiar, you know, but then this is how we work. We have the Emacs or the VI, people have also the VI, and also over here is where we test the command, and over here is where we paste the result of what we want to do it, okay? And quite often, we don't really need to test, you know, we write a script because we have in mind whatever we have to develop, and then you run the full script. So now, for example, if I want to run this script, it's going to be in my directory. So under here somewhere, now I don't remember where it is, under, yes, under media here. So now over here, I have my script that is called script. Okay, is this one, okay? I can run this one, bash. With this one, I'm running this script by bash, okay? Okay, I get, for example, permission denied. This is the first error that I get. So let's see where is permission denied. So input is correct, input, overkill is wrong, input, okay, and output, okay. So now I save it. For save it in Emacs, you do Control XS, another shortcut. And then I go here. Actually, I don't even touch the mouse. I do Alt Tab. I go in this new terminal. I go back and I run. And I get again permission denied in output. Okay, so and here output. Perfect. So again, Control XS, I save it. Alt Tab, I go back to the terminal. I test it. Now it's working. Okay, now it's working, no error. I can see under my, that one was exercise output, where is the X and Y TXT. Okay. So this is how usually we work. We write always the directory over here, and here we type directly. We don't rewrite every time the full path. We don't write the full path, but we just input every directory. Okay. Okay. So something that we can also, something very useful. So please take note of this one. If we do it output, for example, this one, you can you have this command that is read file. I think read file. Actually, I create an alias and now I forgot. So is the alias is alias read link. Yeah, read link -f. Okay, so this one I create one of the alias. One of my alias is read link. So if you do paste clipboard, so it's giving to you, and this is very useful, it's giving to you the full path of this file. Okay, so and then this one is the one that you copy paste over here in the script. Okay, so this is very useful. Read link -f is giving to you this. So Erin is asking, so there is one init.l script that is customized all the Emacs. Frankly speaking, I've been try once, but I use just the default. Okay, so I don't really customize everything. Maybe Longzhu, do you customize your Emacs for some convenience or not?
Yes, actually I do. I saw a message from Erin asking for this init.el, but it's really dependent on system. Yeah, I'm happy to share with it. Yeah, I do some customization. Yeah.
Yeah, you can customize a lot of several links and several keyboard shortcuts, but I usually use the one that I was mentioning in the terminal. So if you do again Control K, you can cut and more than one line, and then Control Y you paste it back, or you can even paste in another line, and then these are and then the same is Control Y. I know Control Y, for example, is not working. And then for saving, Control XS is very useful because every time you have to save before to run, and that's it. And then Control XC is for close it. Okay. So the beauty of Emacs is also that this is very useful from when you work in cluster or in remote computers, is that you can open, because this one is so-called the X11 terminal, the X11 graphical user interface. So when you work remotely, this is the one that is eating memory and is also eating time, the delay between the server. So what we do it, and what many coders do it, they don't open, they work directly in the terminal. So I can open perfect the same script. So this one was the bash with Emacs, and then you do -nv, sorry, dash no Windows W, and over here you have perfect the same, but is on inside to the terminal. So this is extremely fast. You don't need, I can log in from here from my mobile to the Yale cluster. So, and with the graphical user interface, I could not work, but with this one you can work. There are just, they need just a few bytes to transfer it. And then of course you have to have another open terminal to, if not every time that you do something, you have to save it, close it, and then run it. Okay, so usually you open another terminal where you have one for the Emacs and one for the script, for the script. If you are using VI, it's perfect the same procedure, but is slightly different the shortcut. Okay, so I 99% of the time I always use Emacs. Okay, anyone has some editor, especially in Python, there are many editor right now. There is Eclipse, there is PyNote, or something like this.
I use a Spider.
Spider, bravo, Tommy. Spider. There is another one, Sublime, that is also getting really popular. But I have to say the truth that I try, but then because I try, but again, due to that, is not very good in the. Actually, I try only the graphical user interface, and for me it was too slow to operating through the cluster and so on. But Sublime is another one that is quite popular. But anyway, all the Spider and so on for Python, they are a bit better because they give you already the suggestion. You can get the interface. They are like RStudio, let's say, or similar to RStudio. But this is how we operate. Anyone want to share? So, for example, Erin, which editor did you use?
Yeah, I tend to use Atom. It
Okay,
has a lot
Atom.
of packages and that are easy to add on. Yeah, and it can be turned into an IDE if you want it to be, but I just use it as an editor.
Perfect, yeah. For people that are doing report and so on, so for example, the Jupyter Lab, Jupyter Notebook are very good because you can insert plotting, figures, you know, so is for educational purpose, preparing material for, and actually for your final work, you know, you are going to end in the Jupyter Notebook. In this way, we can create immediately an HTML and having your work on the web. Rather, if you have to, with Emacs, you create just a text file, so you will not get the beauty of having an HTML directly created by the Jupyter Notebook. Then, Marlene, which editor did you use?
On the cluster, I mostly open my script in Nano.
Okay, Nano is another one, yes.
Yeah,
Nano.
and on my computer, I decided mostly in the text editor, sometimes also Atom.
Yeah, perfect. There are also some text editor. People using Mac, I don't know the editor in Mac, but there are Nano, there is gedit I mentioned, there are Kate, there is another one that is called Kate for Ubuntu, and so on. But more or less, you can cover it up. You can select whatever you want, but you have some that they have a very high graphical user interface, some other like Emacs or VI that are very basic. Okay, so let's go 1 second. Aphrodite sent me the homework, and she did it with of last week that I gave the previous the previous time, and she did it with her data set. So she it's good that she share just a bit the result, and in this way you can understand the level of complexity, and you will see it's not very long. So Aphrodite, you want to comment, explain the data and the scripting procedure so you can share your screen?
Yes.
And then we will move to the
Can you
Okay,
see?
perfect. Yes, we can see. Yeah, please
Okay.
commenting.
Okay, so I worked on this file where each row is an occurrence record of an insect. So the columns include a dataset ID. So this file includes various datasets compiled all in one file. So we have the dataset ID, we have the coordinates of the location, and we also have the information about the year somewhere here. So first, I used head to see the column names.
Yeah.
Then I wanted to see how many datasets are included in the file. So with awk, I set the field separator as tab, and then I print the second column, which includes the dataset IDs. And then I sorted them and counted the results. Then to count the unique locations, I counted the unique set of coordinates, which are in columns 9 and 10,
Okay.
in the same way. Then for the minimum and maximum year of observations, I printed the column of the year.
Yeah.
But I also had some NAs, some no data in the year column. So
Okay.
I just printed it if the year number was greater than 1. So for the minimum year, I took after sorting all the numbers, the first number and the opposite for the maximum year. For the average year, I did exactly what Giuseppe showed the other day.
Okay, perfect. Bravo.
Yes.
So you did the sum of the column number 16, setting up the variable, and then you divide the full sum, divide the number of row.
Yes.
Yes.
Exactly.
Okay, but over there, so what is happening if there is an A? Be careful.
Here. I don't know.
Okay.
I think that.
Yeah, you have to be sure that in the $16, there is not any NA.
But what if there is an A?
I don't know. You need to test it. You need to test it because I'm not sure if AWK will do the sum and consider NA as a 0 and proceed with the following up, you know. But it will be considered in the number of rows.
Okay.
Okay, because
that's true, yeah.
Okay, so this is something that you need to test and see.
Okay.
So always try to think what can happen to the coding if there is some NAA missing value, you know, something strange.
Yes, true.
Maybe there are no NA, so you can do print 16 and you do a sorting and you can see immediately if there are no NA, so then it's fine. But if there are NA, you have to see what can happen, you know. Okay,
yes,
very
true.
good.
There are NAs. Yeah, so then I filtered just one genus because this file contains several genera. And I wanted just genus occurrences between 2018 2021. So I set the conditions for column 5 and 16. And then I thought about splitting the file to separate files depending on the year of observation.
Okay.
So I used the variables that I set above the minimum year and maximum year.
Yeah.
And I made a loop, looping through a sequence, starting from the minimum and going to the maximum year.
Yeah.
And for each year, I used awk to get the observations of this year.
Okay.
But in order to insert a set variable in awk, in an awk command, you need to use -v
minus v.
and set again this variable. I don't know if there's another way. That's the only one I found.
Yeah, it's this one. You need to import the variable inside the bash variable inside awk. So the minus v is the one that you have to use. Correct.
Too complicated.
Too
Anyway,
complicated.
yes.
Yeah, okay, because why? Because each time that you set a bash variable is in the bash, is not bring, because awk is a completely different software. Okay, so you need to transfer this variable, and there are different ways. So the one that is accepted by bash by AWK is with the dash minus v, and usually you just keep it the same name. Year, that the year, the first year is going to be the awk variable, is going to be equal to $year, where $year is the bash variable. Okay.
Yeah. Okay.
But yes, it's correct. Perfect.
Okay. And then I wrote the file for each year only if the result of the awk set was not equal to 0. So
Not
this
equal
is
to
why I
0.
have this if inside the for loop.
Perfect.
And in the end, in each file, I inserted the header, which are the same column names as in the original file.
Perfect.
And I did this with set minus I1, blah, blah.
Perfect. Very good. So this is for everyone. We didn't mention about this command, this seed, but is a command that is another big software for string manipulation in the text file. So you cannot really do sum between column and so on. You mainly use it, to change or remove space, to change it from one word to another one, or remove all. If they have two space, you can take out the two space to one, or changing the word. I have AB, I want to change to ZT or whatever. So it's very useful for this case, this operation. Okay, very good. So this is the kind of scripting procedure that we expect for the compulsory assignment. Again, if you don't have any file, you can use the gsim file, or if you have something that you are operating, feel free to use it. Okay. Any question in this regard and so on? Okay, perfect. So we move to the scripting, sorry, not to the scripting procedure, to the okay.
Can I ask one last question about?
Yes, please.
So it was kind of related to what Aphrodite was showing us, but do you want to try, because like right now with the assignment, I've figured out, all the things we want to get. I haven't figured out how to like put that all together to write a file. But do you want to save like, if you're pulling the year, for example, do you save it as a variable and then write the file using that variable name, or do you want to just, put that command directly in when you're writing the file? If that makes sense.
I mean, whatever. It's important. Whatever you find the solution is fine. It's important that you show that you are using the tools, and then if it's not perfect, what the one that we're going to use it, but it's fine,
Yeah.
So, for example, you were so the same result can be done in a different way. Okay. And maybe even if it's not perfect, the same result is slightly different, doesn't matter. It's important that you use it. So feel free to test it and use it, and then we will show how we would do it, or maybe how Longzhu will do it on for that particular case. Okay, very good. Okay, so any other question in these regards? Okay, perfect. So we move we move to a new topic that I think is very exciting for all the people working in the geography in the environment, and is the use of GDAL and OGR. So here is where we operate indirectly. We have been operating with Barsh's seed. We see also OWK in text file, but now it's time to operate in geographical data that can be represented as a raster file or as a vector file. And we will see the use of GDAL for the raster and OGR for the vector file. So this one you can already see. I'm going to cover the GDAL under the GDAL item. This one, use GDAL OGR for raster and vector operation in OSGeo. Please don't click the collab because it's another page. So this one is the one that we are going to tackle, and we are going to using the notebook that is already stored inside inside to the virtual machine, to the data. So as I mentioned before, be sure to enter in the SE data and do the git pull like I did before, and then migrate inside to the LVM. Yes. So I will copy this one here to be sure that I have in the same directory. Okay, so I'm going to open perfectly the same file. So I'm going to enter in the exercise, and then I'm going to open the GDAL OGR for OSGeo, GDAL OSGeo. And I'm going to use, and this one is the same one that is going to be here. So even if you get lost, it's very easy. You can see the same GDAL and OSGeo. The GDAL OSGeo name is perfectly the same. So you can see Jupyter Lab. You can open Jupyter Lab. So, sorry, I need to open the source. So Control R, source. I need to open the, to sources the Jupyter Lab environment in order to be able. So I do again Control R, then I type source, and then I can enter. So now I'm in the Jupyter Lab environment, and I can run now Jupyter Lab to open my exercise. But sorry, better to do like this: CD exercise, enter in the exercise, and then open the Jupyter Lab. Okay, because in this way all the password will be correct. So now it's opening. So this one you leave it open, you don't close it, but usually I just minimize, and I'm going to keep another terminal over here for some fast checking of what I'm doing in the Jupyter Lab. Okay. So so first of all, the GDAL OGR in a few words is a library that has been built up for sure now already 20 years, and you can go directly into the GDAL OGR page, org page, and this one has been growing tremendously in the last 10 years. When I started 20 years ago, it was just a very small page with a very few commands, but now there is a big activity behind this GDAL, and GDAL is really the backbone of all the geographical software. Okay, so over here there are going to be programs using no, these are the raster program. There is another one that say software that are using GDAL somewhere, and you can see that all proprietary software and open source software, they use GDAL. So if you go over here under programs, you can see that they are splitting immediately in different groups. And some of them, as I mentioned, they were in the beginning when I started was GDAL Info, GDAL Translate, and GDAL Warp. That's it. Now you can see the list is getting longer, and if I don't check it every 4 or 5 months, there is one new one coming up. Okay, so try to have it always have a look to the web page, because there is always something that is coming out. There is also the other one. Let's go direct. So this one, the older one that start with GDAL. So be careful that sometimes you have GDAL underscore and sometimes it's just directly. Don't ask me why they have this difference, but anyway, it's like this. And these are going to operate for raster file, rather the other one, the OGR, are the one that operate for vector file. Okay. For vector file. Then they are going to be also they have this one multidimensional raster program is for the so-called data cube or data array cube. Okay, that is something. So the temporal analysis for temporal time series. Okay, so where you don't have only one raster, but you have several rasters stuck together to represent each one. For example, represent the day, and you have the full year of daily temperature. And this, I have to say the truth that I use it only one, I think the GDAL info. So I didn't explore very much this one. And then there are also this one, that also this one are quite new, geographical network program for managed network and for network vector network, like a stream network or a street network. So also this one I didn't use so much. The one that we're going to use it is going to be the raster environment mainly, and I will show also the vector environment. Please consider that for the massive data process, we are going to is more convenient and from a computational perspective using the raster environment. Even and the vector is going to be used just for final visualization. Quite often, you will see people, especially that work in the municipality level or regional level, using the vector environment. But as soon you go at continental level or even country level, all the street in Italy, a vector file will be extremely heavy to process. And also because, and this is mainly due because for each single, you have the vector file, you have a line and then you have a dot, and then you have another line, and then you have another dot, and each dot is, each node is going to store geographical information. These geographical information are not setting in a matrix, so the computer is going to be always computationally intense to process vector data. Okay, we have been using creating vector data for a stream network. They have been released. And the file for in the vector format, they are 6-7 gigabyte, and the tiles just the tile in a raster format just 400 or 200 mega. Okay, so that this is the difference. So it's not only a storage, and then of course when you have a high value of high size of the file, then you need high time to process that file. Okay, so that one is the one that you have to always consider. If you see over here, the raster drivers, so are all the format that that GDAL support, and you can see that they are supporting many of them. Okay, I would say all of them, from the new, I mean the new HDF5, HDF4 and 5, for example, you have over here, and each one that you click over here, there is a huge, very huge, and is changing from format to format. So the page for the HDF5 is different from the T file and so on. So always having this one very careful over here. And or the other one that is also used a lot in the raster environment is the net CDF, especially people that are working in climate, net CDF. And this is very common from climate data. Okay, so also this one is supported by GDAL. And so on and so on. The one that is more is the default in GDAL, that is the one that quite often, I mean, we often use it, is the so-called TIFF. Okay, the GeoTIFF, this one. And also for the GeoTIFF, there is a very big information about in this manual. So also about, because then each single format, you know, accept particular compression. He has an internal structure, like the HDF is a hierarchical data file. So he has a sub-level like the next CDF. Rather the TIFF, there can be one band or two band, that's it. Or yeah, even more than one band, but at one level only. So they even treat the no data in a different way, and we will spend a bit of time on this. So it's very particular how you treat. As I mentioned, is the default. So when you are using TIFF, the output is going to be automatically TIFF, and you never need to specify the format. So you can always saving time because you don't need to specify the input output. So the no data value, I'm going to read a bit more about this one. And so these are the creation options that you have to check because they change from format to format, and we will spend a lot of time in doing this. They sort of accept multi-threading, okay? But I have to say the truth that quite often I try to use it, I don't see any performance going better. Also because most of the time the multi-thread is just doing for during the compression. So there is not an easy way, let's say, or a directly way to use multi-core in GDAL, apart from GDAL warp that has been very carefully checking. Over there I could see the use of the multi-core, and I can see the improvement. So, but it's something that you need to be really careful and looking. And I mean, if you put it, it's not going to give you syntax error, but you don't see any improvement. So we are going to check all of these one. And in the beginning, it can be a bit frustrating and working with GDAL and reading all this information because you have to enter also in the terminology that I use it and so on. But in the last 10 years, like I mentioned, this manual is becoming really good. So, so you can really find a lot of information. Okay. So let's go, for example, to the GDAL, to the command programs, and let's comment a few of them, and then we will see in the real case this one. So one of the most uncommon and the one that we are going to use is the GDAL info. And as you can see, these are directly implemented in Bash. So if you do GDAL and then you press tab twice, you can see all the GDAL command that are there. So remember, press tab twice. And you can see that they have the Bash syntax, okay? So you have the GDAL info, that is the command. Then everything that is between square brackets is compulsory, is optional. And the one that is not is compulsory. So for example, GDAL info plus the file name is giving to you some information about the file. So all these one are the so-called option or flag that you can specify. And each one over here are listed over here. So you can get the information about the minimum maximum value of the image. You can get the histogram. I really don't like it. We will see PK tools for getting the histogram of the image is much, it's done in a better way. And you can do, for example, these are very new one of the file list. So these one are very new. This one, I didn't really use it so much. And then there are the projection information, reporting the projection information, and so on. The beauty also that is something that they adding, for example, is an example. And okay, for GDAL info just one, but if you go in another page, there are even more than one. So for example, if you do the GDAL info of this UTM file, you can see immediately that you have the size of the matrix, so X and Y number of pixels, the projection information, that is something that you have to always look, and we will spend a bit of time on this, then the pixel size, and the upper left and lower left, and so on, the corner of the image, okay? Something extremely important and you can immediately identify is when you work in UTM, so in meter, and you can see immediately that there is a big number over here. Rather, you can, if you are not working in UTM, you have a really small, really small number. You have a number that are between 180 and minus 180, okay? So this is something that you need immediately understanding from here. And okay, from here you cannot guess it. I mean, you cannot having 60 degree of map. If not, you will have just 20 boxes for the full globe, you know, or even less. So, but by this one, you can immediately understand is UTM is a metric system or is a degree system. Okay, and we will see the difference between the two. Now, this one is one now that I see. These are the two big guys behind the GDAL, and they are very awesome. They keep the GDAL at front level for all the geographic operation.
Giuseppe,
That is maintaining all the software, and they are maintaining the software, and they are providing big input to the society. Somebody was asking something?
yes, I want to ask you if you know what color interp mean, like way in the end of the code or the response of the GDAL info.
Sorry?
In the end of the GDAL info, there's color interp. What does that mean? Below the coordinates.
Over this one?
Yeah.
Okay, perfect. So this is the gray level if there are some color table associated to this file. Okay, for colors. Okay, so in this case, just for colors. So in this case, and most of the time, they are quite often they are gray, or sometimes you have the RGB in case you have satellite image. Okay, so when it's gray, you open and you will have just gray image from black to white. And rather, when you have RGB, you can have also the satellite, and you can combine this RGB. But anyway, this is something that there is not influencing. This one is not influencing the pixel value. The pixel value is always the number that we will see. It's just influencing the color representation. Okay, so I will not worry so much about this. What I will worry is about this one, and we will see now. We will spend a bit of time, and also about this. Okay, and so on. So let's go to another one. For example, GDAL translate. Okay, this is a very old one, let's say, but as I mentioned, also has been increasing quite a lot in the last years. All this information over here. GDAL translate is they translate software, and scripting procedure is mainly for translating format. So you can go from PNG to JPEG to JPEG 2000 to TIFF to whatever you want to change. In the meantime, you can cropping, changing pixel resolution, not warping, not changing projection, but just changing pixel resolution, changing the data value, making some resampling technique, and you can specify the kind of resampling. And over here, you can compress the file. Most of them, all of them, they compress the file. All the GDAL compress the file, but you need to specify the compression, and we will see. So over here is the typical example of GDAL. Okay, so you can specify the band, and so these are the examples that you can find. There are not so many. There are 3-4 examples. So most of the time you are going to rely on the example on internet in order to find some other. Then another one very important is the GDAL warp for warping the image. So in the meantime, warping is the change projection. You go from UTM to VGS 84 and back, or to other local system and so on. these, like the change projection is very annoying sometimes. I mean, I didn't do it so much for a simple reason, because I'm working always in the global scale, and 95% they are very well done, and they are already in VGS 84, maybe in some modis, for example, some sinusoidal projection, but due to that are global level, and they have been tested by NASA and USGS and so on. So they are always very well standardized. The one that is really making you crazy, you and me too, is when you're working with local data, municipality data, and they are in different projection according to the different country. Over there is just a matter of try and try and try until you get perfect overlap, okay? So there are some rules that you can guess it with experience, but it's just a matter of trying, okay? Also, Longzhu is always making me crazy for this change projection. He's going crazy for this. Sometimes it's not able, it's not easy, an easy issues. Anyone is using some particular command over here in GDAL that say, I didn't know, and when I discovered it was saving my life? Anyone was using and want to share his opinion on this? They said that one was very awesome that I found it. Anyone? Show me, you were using GDAL?
Oh, yeah, I used for the.
Oh yeah, go ahead.
Yeah, for the modis data, when you install it, you get the HDF version of it. So I used to use GDAL Work and GDAL Translate to translate it to TIFF. Yeah, that's all.
Yeah, bravo, very good. The HDF, they are mainly Landsat and models that are being released in HDF, and also now the new GDAL dataset, and also the ISAT. These are hierarchical together with the NetCDF, the HDF. They are considered a hierarchical data file because you can have sub-level, and when they have this sub-level, sometimes it's a bit tricky to use GDAL. So very good that you were using, Julia. Maybe for next lecture, you can show us the line that you are using for changing from HDF to TIFF.
Yeah, sure.
And because it's quite tricky. If you don't know, you can spend a bit of time in using these hierarchical data file. Then anyone else want to share his experience on this? Something very awesome. Erin.
I don't have an awesome application right now. I don't know. I can't think of one.
Okay. Somebody want to say something? Okay. Okay, so let's go to let's go to OGR and briefly explaining also the OGR system. So you go in programmers again. So you go down over here. You have mainly two that we quite often use. The OGR info is for checking information about the file, and few days ago, Alonso was asking if you can use Oak or Bash for reading the DBF or of a shapefile. So this is how we are going to use, and it's possible, but you have to have an interpreter of the DBF file, so the OGR info. Okay, so this is the one that we can use it for listing this information. And the OGR to OGR is the let's say the brother of the GDAL translate and GDAL warp, because in the meantime you can do it the warping of shapefile and so on, vector file. And something that you can also do it is quite often we do it. You do the clipping by X and Y coordinate. You can change projection. You can do a lot of almost all the operation that you can do in vector. is supporting also the SQL, so you can do statement in SQL inside to the OGR to OGR, and we can see really few examples of these, and some of them are really new. But you can do overlay, you can do union between files or from between vector. So it's really, and usually is where QGIS or ArcGIS fail. Let's say over here is a matter of time and testing, but you can do it almost everything. So I use it quite a lot. Okay, then there are also some other OGR tile index is to create index. And if you have a tiling system, tiles, you create a shapefile from these tiles. This is also something that I use, especially for sharing, for visualize the position of the raster in the globe. Okay. Okay, perfect. So let's do a break, and then we will start it with a hand over here, and we will come back at 25. So 20-minute break. Okay. Okay, perfect. Okay, perfect. So now we will start the hands-on on GDAL, and we will discover the command that most often we use it. Then is a matter of to see the combination of all of them. So you should be able to open directly the Jupyter Lab notebook. So once again, we are using this one, Jupyter Lab, and then GDAL OSGeo. And remember to do the git pull and the rsync. In particular, this one is the web page. Is the page, and it's also the web page that is over there. And we are going to see command by command, and I will keep using the terminal for some troubleshooting or maybe just some visualization of the file. So as you can see in our directory, we have plenty of data set coming from different sources. Most of them, as I mentioned, we always use TIFF as a data set, as a format for raster, and I don't really use it other format. As soon as I get from other format, I immediately convert it to TIFF. So this is my way of working. And here you can see there are divided in different folder under the geodata. And usually you can see over here that I'm trying to classify them, or at least to grouping them in according to their sources. So let's say vegetation or temperature, digital elevation model or cloud, and so on. So this is the kind of structure that you have to try to always keep it to have a good organization of your file. Okay, so one of the typical example, one of the first command that you're going to use it is the so-called GDAL info. Okay, so GDAL info is giving to you information about the dimension of the matrix, so the X and Y, row and column. So column and row, because it's always X and Y. And over here you can see the pixel size and also the geographical information. Okay, so something to keep in mind, this one together with the projection information are the one that give you information about in which system are you working. One of the most common one is the VGS 84, this one, that is for the lat long projection in the global at global level. So most of the time when you're working with command line, when you're working at global level or continental level, you always use the VGS 84. Okay, so immediately, as I mentioned, you can see that you are working due to this, but also due to this, you can see that you are working in degree, okay, because they go from -20 to minus 180 to plus 180, and then -90 and plus 90. So you can immediately see the dimension of the X and Y coordinate. Rather, if you are working in UTM, so this one is another example of UTM, you can see over here the projection information that are different, okay? So, and usually they have the meters, this one I was searching, the meter system over here, and you can see immediately also that the file are much bigger, okay? And when you are working UTM, they are working in zone of the UTM area. So by this one, again, by this one is something that you can immediately see how big is the, if they're working meter system or in degree system. Something also important is the pixel size, you know, and the pixel size also, this one give you some direction about, because 300 cannot be in degree, because if not, it's more than the 2 pixel, you have even less than 2 pixel, you have the globe, and but can be meter in this case. But if you have something like 10 or 1, can be meter or can be even degree. So together with this one is the one that are giving to you information, okay? So something that you need to always consider, especially when you work in degree, is the dimension of the pixel, and to understanding where is coming from this number and how big is this number is good to have to keep in mind. So try always to remember this one, 0.20 and then 83333, okay? And this one is more or less 1 kilometer at equator. Okay, why you need to specify an equator? Because when you go up to the north, up to the south, the latitudinal gradient degree reduce the size of it. So it's not anymore 1 kilometer, but it's getting less and less going from the equator up to the north and other way around too. So that number, anyone knows where this number comes from? Any idea about this? Something that you were always try to guessing, and but you never figure out, or something like this? Anyone can tell me? Erin, you quite often see this number, or this one, or sometimes also less than that one, okay? So this is where it's coming from, is the 1 degree divide 120. Okay, 1 degree divided by 110, and 1 degree divided by 120 is this one, okay? Is the number over here. That, as we say, is more or less 1 kilometer at the equator. So if you remember this one, then you can immediately remember all the others, because this one is going to be divided by 10. Okay, divide by 10, just another 0, is not the 100 meter, but is getting close to the 90 meter, and they call it 90 meter. Okay, and then all the rest, if you have some particular, but if you remember this one where it's coming from, then you can reclassify all of them. Okay, so this one is also the 30 arc second. Okay, 30 arc second is y is equal to 30 arc second. Okay, and why? Because is, you know, you have 120, so is, you know, is 1 divided by 60 divided by 60. Yeah, so it's 60 divided by 2, so it's 30 arc second. Okay, so when you keep in mind this one, let's put also the 1 kilometer, more or less, like we say. Then from here, you can immediately understanding, if I tell you 7.5, how much it is, and say 7.5, or yes, for example, 7.5 is going to be, you know, 1/4 of this one. the 7.5 is going to be 1/4 of this, and is going to be 1/4 of 1 kilometer, so 250 meters, okay, and there's going to be 1/4 of this. So this is where it's quite easy to, so if you get this one, do the upgrade, but later on, don't do it now. So this is where you can do the pixel transformation, okay? So, and this is very important when you have to go, for example, from degree to UTM. So if your pixel accuracy is this number, 0.08, you have to transform in UTM having 1 kilometer resolution pixel, okay? So you cannot become, okay, you can do it also something intermediate like 900 meter, but cannot become 9 meter, okay? So, and the other way when you go from UTM to this one, okay? So keep in mind these numbers that are, and from the other you can rely on all of them. Okay, now more clear this concept. Anyone you were doubting, you say, ah, now I get it. Finally, somebody explained me where they come from. Okay, Erin. Yeah, is it clear? Yeah, cool.
Yeah, I knew that it was about a kilometer. I just didn't know about the math behind it. So no, it's very
Perfect.
helpful.
So this is the math behind. Yeah.
Well, actually, just one question. So you divided 1 by 120. So 120, where does the 120 come from?
So is the 1 degree divide 60?
Mm-hmm.
60, sorry, 1 degree divide 6, oops, divide by 60, why that doesn't type 60, and then times 2.
Okay.
So it is twice the 60. So that's why 120.
Gotcha. Okay. All right. Gotcha.
Okay.
Yep.
Perfect. So anyone rely on this? Was happy to have this explanation. Did you see? And feel free to ask some of these questions that always bother you and you didn't find a solution or a reply. So something to keep in mind that has to worry about it, and it's something that I struggling a lot to let the people doing, and maybe also Marlene, Aphrodite that are working for us, they start to see the importance in having the pixel, the extent of our coordinates, and also the pixel size really rounded to the decimal point, okay, rounded to the decimal or to the integer point. So this kind of situation where you have pixel size that are different, okay, and in particular, they can never, a number like this can never match, you know, an integer value, or quite rarely, an integer value when you multiply. And this kind of error, this kind of precision, you can really have a big mistake, or the so-called pixel shift, especially when you work in the global level, you know, because some small difference, when you accumulate down into the big matrix of the global implementation, so these little rounded is something that you can make shift in the pixel, and the problem that you don't realize, because they are so small, there are so many, but they is not warning to you, so it's coming up later on in the computation, and that you see something strange that you should not happen, but not as a syntax, but as a pixel value that you should not have it, and then you start to go back. So it's very important to have the pixel, the alignment of the extent, really like this one. Okay, so with the pixel value, really, in this case, 0.8333 and so on, and with the integer extent, or at least if it's not integer, maybe just this one, 1, and then 0, 0, 0, and so on. Okay, so quite often, especially people that have been working with, or they do output in from the R start to rounding around this now I don't remember, after 6 or after 8, start to rounding this one, And again, is going to later on, especially if you are working with one tiles, one image, you don't see any problem. But then when you start to tiling and mosaicing all the image, then is where you can have 1 pixel missing, and it is due to this. So with the use of GDAL edit, is you can correct these little rounded and having the pixel size. So it's not a resampling, it's just a correction of the pixel size. So over here become, if you have 7, 4, whatever, you can become 3, 3, 3, 3, 3. So and this one is very good to do it in the beginning in order to have all the data set aligned to the integer level and so on. And knowing the math, you can identify the number. So for example, at 7.5 degree, so you do just this one divide by 4, and you will see that is the 0.28333 is the one that you can get, and you need to transfer over there. So whatever it is, if you have something very close to that one, maybe start to become 785. Don't worry, just change it to that number. Also, because if you start to do the math, that digit over here is going to be 1 centimeter. Okay, so having, let's call it a little shift of 1 centimeter in your computation, but no mistake in the matrix, is much better than not having this mistake later on. So it's something that I really stress it quite a lot for this aspect. Any one of you was aware or was dealing with this kind of and it's full, it's full of, when you downloading data, to see this rounded and this not very good alignment and so on. Even global level. I'm not talking about municipality level, municipality files and so on. Yeah. Okay, so let's move to another topic that we are maybe one of the few that explain this stuff in the GIS, let's call it, in the GIS environment. Is something very important for the understanding how the machine, how the type, the file is built. And now we are going to talk about the data type. Okay, this one that is specified over here. Okay, this is something also that when I was starting the GIS, for me was just, I don't know, byte, floating, integer, unsigned, why I have to select the how and so on. Until later on, I found this table. I make it longer because in this way we can see everything. I find this table that is coming from the GRASS webpage, where explaining the data range of this data type. So in particular, so this is very important to understand, because having a data type setting correctly can reduce the amount of space. You can see that the same image, if you just change the number of the data type, increase the size, okay? But the value is still the same. The pixel value is still the same. So having image save it in the right way is extremely important. So let's see a bit about which is when we are going to use it, each single data type. And this is, you can change, you can see by using GDAL info. So again, you can see over here, float 32. Over here you have the you have it the 250 the byte. Okay, so for example, the byte goes from 0 to 255, and then Longzhu is going to explain why and so on, all this stuff. From 0 to 255, and for example, usually is the typical situation where you store it, for example, land cover, because you have 20 land cover, 40 land cover, so you're never overpassing the 255 value. Then, for example, you can say you can have the unsigned 16 from 0 to 65. Okay, 1000. So over this number, you can have it. And if you have some value that they are going to be over this number, they are going to be, if they are bigger, they're going to be to round it to this number. And if they are less than 0, it's going to be rounded than 0. Okay. So this one, for example, is going from minus 32,000 to up to 32,000. Okay. And and so on for the order. So these are all the data range, all of them. So you can see that you have some number that you can really recognize, like these recognize. Sometimes you can see that these one are becoming no data value. Okay, sometimes, especially R also, Python, not sure, but especially when you do some default, you see a big number as a no data value. This is the value where it's coming from, or even this one, the 3.4, or even the extreme. So sometimes, quite often, the extreme are considered the no data. So when you see a big no data number, like the one we will see below, is where it's coming from. They are the extreme of the data type. Okay, let's suppose that you have a digital elevation model of elevation in meter. So in which data type you are going to save? Anyone? Digital elevation model, so the extreme where they can go, global one.
You should be able to use the unit 16.
Sorry, this one? Or unit 16?
Yeah, this.
Okay, what about that Valley, Black Sea?
Yeah.
Okay, so you need to go.
Next one.
Okay, so why? Because you know, you have some negative value below 0. Okay, but then you have the extreme 8,000, whatever the Everest. So this one, you can start to use this one. If you start to use this one, you will, and you have a digital elevation model. Let's suppose you have a digital elevation model that is in float 32. And I'm going to convert it in unsigned 16. But all the Dead Valley and the Black Sea and all the Netherlands area and so on, they will become 0 everywhere. Okay, because they will be considered negative, and when you do the transformation, they're going to get the minimum value of the data range. Okay, so so the floating, so this is where you have to be careful about. Or another example, land cover. Of course, I'm not going to have 32,000 classes of land cover, so I'm going to use the byte. Okay, so this is where you say that, for example, all the Landsat image, you get a so-called digital number. So these one are in byte, okay? Or some modest product, they can, most of the time, they always try to keep this one, the byte, the unsigned, byte unsigned, yeah, all these one, the integer one, because they are the one that you can compress much better. They occupy much less, okay? And of course, when they are less, it is even faster to read and to process. It's not only a matter of size, it's only a matter of time in the processing time. So something that you have to consider is the floating 32 if you want save it, not integer number, okay? But also here, you need to be careful. Do you really need to use 34, because this is 38 value, because it's going to store it, even if it's 2.1, after the 1 is going to be 0, 0, 0, 0, 0, 0, 0 for 38 times. And even the floating 64. So there are something extremely carefully that you have to select this number. If you have calculated the vegetation index and DVI, so in that case, you need a float of 32, okay? So don't go in the float of 64, because if not, you will have 64 digits that you will never use it, you know? So, and then sometime, for example, if we want to save it temperature in Celsius, global level, so you know that it's going to minus 100, somewhere in some Arctic zone, to plus 100, let's say a bit less, 50 in Sahara and so on. Okay, so which one you are going to use it? On this one. So Celsius, in Celsius. So which one? Anyone? Which one of these we can use? Come on. Celsius, we need to go from -50 to +50. The one that's most convenient.
Well, don't you need to use the float if you want like fractions?
Okay, we will go there. Let's say first we need the integer one. Okay, I need to save temperature, save a temperature file. I need to create a temperature file with the integer value Celsius. Okay, so I'm going to use this one because it can go from -50 to +50. Okay, I don't have any other that can be negative. This one, but it's too big, so it's useless. Okay, so I'm going to use this one. Okay, because -50 +50 is including in this range. Okay, can I use, and then let's suppose that I want to keep it 1 digit after the comma, so 2.1, 8.4. Okay, so like Sebastian would say, so which one you are going to use? Anyone? Janus.
So we have command, we have to use float.
We have to use float, but yes, as a first question, but can be more clever and save space in computation and size. If I multiply by 10, is becoming this one. Is going to be the -50 is going to be -500 or +500, and then I can set it as an int. Okay, so just multiply by 10, and probably the temperature storing more than 1 digit is, you know, it's more than enough, more than 1 digit after the comma. So you don't need to save it. Okay, 2 digit, but even 2 digit, you can multiply by 100, you're still over here. So you don't really need to store it temperature as a float of 32. And for example, the WordClim, so famous WordClim database has all the file, almost all of them integer by multiply by 10. That's why they multiply by 10. Okay, so it is mainly for saving space and computational time to work in integer. So try as much as possible using an integer. Okay, of course, again, you have to work in NDVI, fine, float is 32. But again, you can even multiply the NDVI by 1000 and it's going to be fine. So it's really depending what you have to do it and how you are going to work. So each one of these they have a boundary limitation, keep in mind, but in particular, the float 32 has also some floating precision issues. And now Longzhu is going to go deep on this one, and please keep attention because it's very important when you do some mathematical calculation. So Longzhu is going to cover a presentation that in particular you have it over here. So if you do, you go in lecture, over here there are all the lecture always. And you see this one is the one that Longzhu is going to use. Okay, so Longzhu, the floor to you.
All right. Okay, so just change a little different speakers. Giuseppe asked me to prepare a little presentation to explain this floating representation, where we see in the used, very widely in GDAL. So I'm going to share screen. If I can, let me start sharing the screen. Do people see my screen?
Yes, I can see it.
Okay, perfect. So yes, as we know, mathematically we deal with real numbers. That's most cases Giuseppe explained. No matter is the the temperature or is this degree presentation of spatial resolution. However, there's one thing we have to keep in mind. We have to represent those numbers in the computer system. And the way to do it is so-called floating point system. That's what we're going to cover today. So basically, any number in a computer system is represented in such way as shown in this formula, where x you can see as a number, a real number. It's basically broken down into several parts. So plus minus is just sign, plus number and minus number. Then we'll have d, beta, and some exponent. So we can go just briefly what it means, and because it's relevant to what we're going to talk about later on. So beta is a base. Basically, we're talking about a decimal system or binary system. And as we know, in our modern computer science, we mostly use binary system, basically 0 and 1. That's what beta is. And D is pretty much the digit. Like in decimal system, you have 0.1, 0.12, 0.135. So any small digit after the dot is what's represented here in D. And the very last one is a beta to the exponent E. It's called the exponent that determines how big the number will go. It's like a scientific notation, more or less. So the Z is bounded by the L and U, which is lower and upper bound. So this is basically how computer stores numbers. And just a middle terminology, all these D's together are called together as mantissa. And if you remove the first one, it's called a fraction. And this sign, exponent, mantissa are stored separately in the computer. There's also a normalization mechanism. Normally D is always non-zero, so that we can say one digit. That's just for the sake of efficiency and use. Now, here comes important thing. So as you realize, any number, any real numbers need to be represented in the formula before. That means we have to squeeze the infinite space into a finite one. What I mean by that, it means if you look at real numbers, I think we all agree we have infinite number of real numbers. There are countless. But however, when we have a mathematical presentation in the computer science system, we have finite number and discrete presentation of the real numbers, which is can be counted in such a way, which I show in this blue box. That's the total number you can present in any given system, if condition on you provided that particular parameters beta, u, and everything else I explained before. So it's not important to parse this formula. What's important is that to realize this number, whatever in this box, is finite. So what I mean, that means some numbers can be presented precisely in the computer system, while others not. So let's just show a toy example where I have this parameters beta equals 2 means binary system, precision means 3, it's a very low precision system, and exponent goes from -1 to +1. So if you do this and plug this in to the formula I showed in the very beginning, you'll see something here, which is a presentation of all the numbers can be represented precisely in this particular system. So you can see 0 in the middle, then it's going left all the way to -4 and going to right to the +4. You see that there are several vertical bars between 0 and 1. There are actually 4 of them. But if you go further up, the vertical bars between integers are getting less and less. For example, there's only one vertical bar between 2 and 3. That means 2.5 is in the middle, can be presented precisely in the system. But if you want to present anything other than that, between 2 and 3, you cannot. Let's say 2.1, you cannot present precisely. 2.8, you also cannot present precisely. Just put this system into our reality. That's actually exactly what happened in our computer system. They are pretty much two kind of precisions. One is called a single float, the other is double float. Just by judging by the name, single float has a lower precision and double has higher precision. It's clearly illustrated in this graph. As we explained before, the computer will split this sign, exponent, extraction into different parts in the system to store a number. So you see here, because this double precision has more exponent and also have more fractions, that's why the numbers presented in the double system is more precise than a single system. So just to give you some little big summary, the machine numbers are not exactly presented. So that's why you have to present something, you are facing the problem of rounding approximation. So some numbers you have to, because the limitation of the system, you have to round it up or round it down. For example, here I'm showing two ways to make roundings. One is truncation, which just cut off whatever the numbers below your cutoff. And the rounding is pretty much, as we're familiar with, is a rounding toward even. If it's about 0.5, you go one step up. If it's between 0.5, go one step down. So I think I'm getting close to the important, so this is also related to machine precision, which is pretty much defined by the parameters I showed before, is beta and p. That means how precise your system can represent a number. So now we're going to go to some examples, real life examples, and we'll work with you together to see how this presentation of real numbers in the computer system can cause potential concerns if you are not careful. So this is the first example, which is a Python code. I think most of you are coding Python, you are familiar with this. So basically, input NumPy, I upload the NumPy package. Then I do a NumPy arrange, basically gave a range, right? It range from 0, which is lowest, up to 1, and the highest, and at step 0.1. Then I ask a test in the Python code for this sequence of numbers to see if there's anyone equals to 0.6. Now, the question to you is, what is the expected output from this statement? So I'll go back to my screen here. Anybody would like to comment on this? Just by looking at this statement in the Python code.
So do you see any mistake over there?
I would have expected that there is one true.
One. Can you go back to the?
Yeah. So I go back to slides here. So yeah.
0.1, 0.2, 0. Sorry, so I expected there to be a true at the 6th. So that it's going to be equal to 0.6 at, sorry.
Yeah, in the output, right? Yes, you're right. So basically, what I did here is I provide a sequence. The number from 0 to 1 is the output of the NP arrange 0 to 1 at step 0.1. You just print out 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6 until 1. So mathematically, at some point, there should be a particular instance that you expect a true outcome in the result. but in reality, you don't see. So the reason for this is because these numbers are not presented precisely. So in other words, every word, every number I show here, as you've shown, that's mathematical meaning, for example, 0.6. But when you put 0.6 in the computer system, it has been transformed into its approximate representation. So it's very close to 0.6, but not exact. So yeah, thanks so much. That's very much clear. Let's do another example, which is I'm showing here. This is a C code. For those of you who are not very familiar with the syntax, I will just explain briefly here. It's very simple. Basically, I define 3 variables, x, y, and z. So the x is a big number, y is 1, z is 5. Then I print output, 3 outputs. One is x is 12, then x plus 1, then x plus z. Then the output are listed in the very bottom. Now, do you see any issues here? Anywhere else?
Yeah, the last value is 20. I would expect, or whatever the number, +4 instead of +5, I guess is what it looks like.
Yeah. How about this one in the middle? And this, the number in the middle. Do you see any problem over there?
Yep. Also has not increased.
Yeah. So it's some like one somewhere missing, right? So this is another example. The number, when they are presented, they're not presented precisely due to some rounding errors and the machine precision. You lost some numbers over there. So it just become how significant it is. So we're gonna go in depth when it comes to my part to explain the rounding errors and the machine operations on real numbers and their consequences on outcomes. But for here, I just want to briefly lay out the numbers, their presentation and system, and make you aware there are such potential issues. And this one can be a real important one. For example, if you go to a supermarket and you pay a cash on this amount, 1677216, then you better check out your summation of your receipt. So the computer may make mistake. And that's all I want to say. Thanks for your attention. If you have any questions, please feel free. I'm happy to entertain with some answers.
May I ask what kind of, sorry. Oh.
Yeah, go Miriam, we'll say.
Yeah, please, somebody have questions. Yeah, go ahead.
Anyone facing this kind of problem.
So I just tried to do the same computation in my Python and the numbers turned out correctly. So what is your underlying precision potentially, or how did you come up with these numbers instead?
Which one you tried in Python is correctly? I don't think I hear
the last one you showed. Yeah. The last one you showed where you added +1 to the x plus y.
Great. Okay. So yes, the trick in Python is when you use Python, you don't declare the variable type. So in this instance, I literally set up in C to make it single float. But in Python, by default, I think you use double float. That's why if you use double, it's no problem. That's why you have a precise representation.
Okay, very good. Anyone else was encountering this problem in some computation? They say, come on, I should get 2 + 2, I should get 4, but why is not getting 4? And actually, I discovered when I come across one, before I didn't know, I said, come on, this one is wrong. Why should, and actually was very close to the Longzhu example. And then chatting with Longzhu, he said, yes, this is due to the computational precision. Okay, explain me, please. And so for me, it was really, I don't come from computer science, so I don't know this stuff. And was very relying in, I was very happy to understand why sometimes, so if you have some mismatching of, could be that you are that you are making some mistake in the computation precision. And that's why go and sharing again. That's why you have this situation over here. You have this bounding over here in the floating 32. So what does mean? That if you in the float 32, you can go over this number, okay, but you are losing precision. Okay, so the precision in floating 32 is between this range is good, but over you are going to having issues. So if you are, again, going to the mathematical, so to the example, if you are saving NDVI, for sure is going to be, because that one is between -1 +1, so it's going to be inside this range, no problem. But if you want to use it something the floating, and you have, you know, you have a floating value over here after the 6 that you want to keep storing, but this number is bigger, be careful, because you are going to encounter the problem of making a sum that is not constant, I mean, that is not correct, and so on. And I discovered this kind of problem by any chance. I didn't know before. And actually is not reported in the GDAL. This is something that I presented also. There was a discussion in the GRASS forum, because people that are not coming from computer science don't know this. So it's very important to be aware of this, okay? So anyone knew about this problem and so on, and or heard about machine precision and so on? Jaime, have you heard about this?
Not before. The first time was when I hear you complaining about the issue.
Yeah, well, yeah, the same thing, because I discovered you
Yeah.
I said, come on, this one make me crazy. I lost one week and then chatting with Longzhu, he said yes, because it's computational precision. And in Python, they solve it because Python does not float in 32, using directly float 64. Okay, so be careful about this table and try to keep it on. Yeah, always aside, because it's very important to know about this. Okay, something
that I dropped a link to a BBC article. There was basically back in 1996, there was a rocket launch explosion in Ariane 5 because they didn't basically accommodate for the correct numbers. So
yes, that one I heard about also, this one, and probably because this is floating 32, there is some issues over there that is good not to overpassing this data range. Very good. And in the same line of the extreme value of this one is something that we need to understand very well. What is the understanding the no data value? Okay. And the no data value in the GDAL info, when you run GDAL info, is often if has been declared, is shown over here, because you can have also some TIFF that they don't have this information. Okay, so these are the big number where it's coming. Sometimes you have this number, and probably you have seen this number. These are the one that is the extreme of this. That's why you have the 38 over here. 38 is this one. Okay, so this is where they come from. So probably the people, even if this one, probably the default quite often, if it's not declared also R or GRASS, they put just extreme as a no data value. So now, one question for maybe for the people that already use it. If I have this one question, doesn't mean that I have pixel with this number, yes or no? Aphrodite, what do you think?
What do you mean?
So you see the no data value that can be this number or -999, whatever. Doesn't mean that you have pixel in the image with this number.
Yes.
No.
Why?
Because this one is just a label. Okay, this is just a label. Means if you have a pixel with this value, then I will consider it as a no data. It doesn't mean that there are pixels with that number.
But it's still a pixel, or isn't it?
No, the pixel can be another value. This one is just a label. Again, this is just a label. And means if there is a pixel with this number, I will consider as a no data, but doesn't tell us that in the image there is a pixel with that number. Is it clear, the concept?
Yes.
Okay, so let's try to open this image and we see also how to open. So if you open this one, I'm going to open over here in the terminal. In this way I don't lose, but you can open also. This is with the OpenEV. Okay, OpenEV is a bit old-fashioned software, and but I keep using because I still didn't find another software that is able to be so fast. Okay, so if you do openev.tif, and now if you follow the procedure in the Slack channel, so just to remind you, the one that I pasted over here in the thread, you should have, not this one, you should have everything compiled correctly. So you should be able to pop up the OpenEV. Okay, so OpenEV is not a really fancy GIS tools at all, but it's very fast, and you cannot do a lot. You know, you can change it a bit, the histogram, stretching. You can make even color with this one, show legend and classes, but I don't really use it, really just sometimes. It's very good that as over here, when you move, you can have immediately the pixel value over there and the coordinates. You can change, so you can really understand, okay, what is white, and you see immediately, okay, this value, what is black. Okay, so over here you can change a bit about the coordinate preference, so you can have in pixel, and you can have also lat long information, but you can have also raster and pixel value. So now you will have, over here you will have the 0, 0. Okay, so if you go really in the beginning, you will have the 0, 0, and over here you will have the 700. How much was 750? The size of the pixel row and column. So it's very good for this kind of operation. You can zoom in, zoom out very fast. As you can see, is extremely fast. So now they know data. So if the value of the no data is mapped correctly, so in this case, you will see that is labeled as no data. Okay, so you will see that, this big number is labeled as no data. Okay, so in this case, there are pixels with that value, but they can be image that they have no data label as a 3 point, this big number, but there are no pixels over there. So remember, the no data, when you see, is just a label. Doesn't tell you if it's there, it's not there. So how we can tell that is there, the value, and what does mean? So for example, let's close this one. Or I can even leave it open. Let's leave it open. Oh no, I'm going to change. So
Giuseppe,
yeah.
But wouldn't that label make our raster like heavier?
No, it's just a good question. It's just a text file added to is a metadata added to the GeoTIFF. It's just 4 character, nothing. Okay. So how you can understand if there are pixels, yes or no? You can do it by running the minimum maximum of that image. So let's again get in the same image. If I do it, the GDAL info over here, and I do the -mm, look, the minus minimum maximum does include the no data value. I should have a very bigger number or a very small number over here. Yes, smaller in the negative way, but it's not. Okay. So how I can do it? I can fake the image, giving another value. And now is where you will see Aphrodite. So I'm going to change over here and put in -99 as a no data. Now my image is going to have no data as a -99, but there are no 999 over there. We see the minimum was 0. We see over here that the minimum was 0.4. There are no -99. So at this point, if I ask again the minimum and maximum, I can see that my number, the big one, now is becoming the minimum, but my no data is still the same. Okay, so once again, when you see no data value -99 or any number, doesn't mean that is in the image. Means that if it is there, is considered as no data. And remember, the no data is always a number in the TIFF environment. Can be also an A in the R environment, for example, but is a value. So it's not nothing. The computer need to have something, okay? So did you encounter these kind of issues? And what is happening that now if you open the image, now that has been changed to -99, you open, so most of the time, all the software, including QGIS, if you open an image that has the -9, so the no data map correctly is going to be black, as you can see now is completely gone. So if it's mapped correctly, it's going to be transparent, and before was transparent. Now, okay, the transparent in OpenEV is black, so you don't see so much change. But now what is changing, that all my image is gray. What does it mean? The pixel value over here didn't change, you know, it's just that the stretching of the color, this big number is so huge negative that you need to use the black to cover it up over here, and then the remaining one is becoming all gray. So rather, if I put correctly the value, is going to become back transparent. Okay, so in this case, and when the no data is mapped correctly, so it's transparent, and is also not only from the OpenEV, but is also from GDAL in general. When you do merging and you do overlay and so on, is going to be transparent. That's why in our field, we have we call it computational unit. There are just area in each single tiles, and everywhere else is 0. And the 0, when you overlap, is going to be transparent. Okay, so again, remember that no data is a label, is not, doesn't mean that the value, the pixel value is present. And if it's present, it is correct, is correctly labeled, then is considered transparent for the software like QGIS or OpenEV, but also for GDAL commands. Okay. Anyone knew about this and say, okay, now somebody, now I get it. Why sometimes I have it, sometimes no, and anyone was encountering this kind of problem in this environment, working with the no data value?
I have a question, Giuseppe. So I understand what you're saying about how it's just a label. And so I understand that when you did that command, the GDAL edit, that you're just changing the label of the no data pixels. But then why does it alter the range? Like, why does it then take the value of -3.39? Like, I don't see that in the code. So why did it automatically assume that's the lower limit?
Okay, so when I run this command, I change the label. That I don't change the pixel value. I change the label. Okay, in the image, in the metadata, pixel value are still the same. So what is happening that now my no data, it has been set to another number. And this one is becoming something that you need to color with a gray level, I mean, with the black and white. So the black become this big number, and then you have the full stretching, an empty value, because this is very big negative number because it's time. So all the color are used for nothing, for pixel value that are not there. So rather, if I set it as the no data, then it's becoming transparent. So that black, I can go back to this one. So if I run this, now I go back to that value. And if I open it again, now I will have, this one is black, but in reality is transparent, okay? If I open another image, I can see underneath over here, okay? So now my gray level, it go from, you know, which one was from 0.5 to 5, the minimum maximum that was over here, okay? This one. So better, the concept. So sometimes, especially if you have the image and you open it with OpenAV, you say, it's completely black. No, can be that you are stretching or you are not see very well. So it's very good also to use the mouse and go on the image and see if the pixel value, they are changing. If the pixel value change, means, okay, the pixel are there, there is value, but I can't see very well. So pay attention about this, because many software, including QGIS, consider no data as, and you cannot neither see the value, you know, and you click over there and say no data, but it's a number over there. So it's very important to understand, because then when you do minimum maximum, then if it's mapped correctly, label it correctly, can be included or not in the statistics. Okay, so pay attention about this. And we can see that PK tools has another command to get a minimum maximum that sometimes is better to use that one. Okay.
So is this like a convention? Like, for example, if I upload a raster, should I label no data as the 3.39?
So, okay, so there are some convention. One of the most common one is the -999, typical coming from ArcGIS and so on. But again, if you are in this situation, you cannot have -999 value.
Okay.
So which one you are going to use it? You are going to use it, or this one. Usually you use the extreme.
Okay.
Okay. All the 200. Oh, sorry. All the 250. So this one, or you use the 0.
Okay.
Okay. So sometimes, sometimes even you can use, sometimes you know that all your value are going to be positive of your raster. You are working with a digital elevation model, and you know that you are working where there are no negative values. So your negative value can be -1. Okay, so there is a sort of convention in using the extreme, but then you can choose also another. It's important that you choose a number that is not inside to your extreme value of your variable, of course. Okay, so pay attention about this. Very good question. Okay.
I have a question. So when you're doing the, you gave us the example that we just changed the label. Is there a situation where you would want to / is it desirable to change the actual, like, can you go and pick the number and then change all of them instead of changing the label, actually picking the no data,
Perfect. So yeah, good question. By changing by using GDAL edit, and also in the GDAL translate, you have an option. I think they remove it, but so I think there is an option, no data. I think there was here, but they remove it. Anyway, when you are using these, again, when you are using these, you are not changing the pixel value. You're just changing the labeling. So Sebastian question is, can I use, is there is a way that I can change all the pixel because they are too big, for example, 2 minus 99, in GDAL is not so straight. You cannot, but in PK tools, you can do it with the PK set mask, and we can see next time. So it's very setting the mask and define the mask. Very good question. I don't think in GDAL is so, maybe if you create a VRT and then you change the VRT and then you create something, I don't think it's so easy or so straight. I always do it in PK tools, and we will see next time. Okay, so this is quite tricky and understanding the no data value. But if you remember this concept that is just a label, so doesn't mean that the pixel is there, then you can understanding the statistic that you get and so on. Anyway, when you get the statistics, the pixel that is labeled as no data is not showing here. Okay, it's not showing, but doesn't mean that it's not there. Could be there or not. Okay, because it's masked, it's labeled as no data. Okay. So as you can see, the GDAL is implemented directly in the bash, so we can use all the bash command to combine and using the GDAL. So for example, this one, for all the file in GData vegetation, compute all the minimum maximum of this file. Okay, so and this one is very fast. You can compute it. There are some big raster that you need to wait a bit, but it's going to be computed. This is quite heavy computation because it's going to go screening all the pixel. So the beauty of GDAL is doing really pixel by pixel. Is not doing sampling. Rather, the ArcGIS, it was doing sampling every 10 pixel or whatever. So the minimum maximum was not really minimum max. When you get minimum maximum to really get the extreme value, because this is something that you have to do it immediately. GDAL info and GDAL info -mm to get minimum maximum and to see, are my data correct or not? So if you are working with Celsius, you do GDAL info -- and you start to see 300, 400, 500, or there is a mistake because your value cannot be more than 50 or more than 60, or can be that have been multiplied by 10. Okay, so you can immediately see, or if you would see minimum maximum, you get -999 over here. Okay, means that your no data is not labeled correctly. And when you download the data, you will always find this kind of errors. So it's very good, use always GDAL info to check. And don't check one, you need to check all of them, okay? Because can be, especially if it's not very well standardized, the stuff, you can find error. Okay, check all the tiles and how you make an if condition somewhere here, like now we saw if dollar. So for example, this one you can say if ABUK is less than is negative, just print it and you can see. Okay, so you can play with this if condition. Another one very big, quite a really important command, even sometimes it's a bit is GDAL calc. Okay, GDAL calc with .pi. Okay, something to say, there are some, the one they do not have the extension means that they are in C, and usually they are much faster than the one for GDAL calc. Okay, so GDAL calc has been getting better in the last year. We can go and see, and actually even I see that they have been adding a lot of info, a lot of help. Example, calc, where it is. GDAL calc. Okay. So they've been adding a lot of examples. So here you can see how to do just a normal multiplication. You can see, and this is particularly important, inside GDAL calc, you are going to use NumPy syntax. Okay, so for people especially good in Python, they can really use NumPy syntax to operate between raster file. Okay, so all this one you can see NumPy max, for example, is giving the maximum value of the image. So I think the version that we are using is the 3.3. For checking the version, you do GDAL translate, for example, and then you do -- version, and you can get the version. So 3.2. Okay, I think should work also in the, I don't know why 3.3, but I think should work. The NumPy is working also in the old one. Maybe the NumPy.max is not working, but anyway, the NumPy syntax is working very well. You can do multiple band combination. In this particular case, you need to adding the input, but then from the input 1, I'm going to get band 1. And then from B, I'm going to get, for example, band 2. And this is, for example, is making the average between these two. So you can play a lot. And in our particular case, I was building the NDVI. Sorry, not the NDVI, the coefficient of variation. Okay. So in my case, I was coefficient of variation. So it's going to be between 0 and a big number and any number, but it's going to be a floating point. So I'm going to use the float 32. Again, if I'm going to overpassing the value, this dangerous value, then I need to be careful. But if it's less, I don't have to worry about precision. So this one, you can see again that these one are the data type that I need to specify as a float 32 and so on. Okay, so consider that this is a bit tricky because NumPy is going to use, as Miriam was mentioned, is going to use float 64, so double precision. But then GDAL and the GeoTIFF is going to be stored with float 32. Okay, so if you are passing this particular number, these two extreme, you cannot use float 32. You have to use float 64. So pay attention about this, okay? That are quite tricky. So you can always, if you like, you can always open the file that we create, you know. In this case, is, yeah, you can open always with, so GP vegetation, GP. So as you can see, I didn't click, I just click, okay, I'm going to use CV, no? And you can open. So over here is where, for example, I can see immediately that my no data is not mapping correctly because I can see, you know, the label over here is not show no data. So then so over here is perfect. So I need to a GDAL edit to labeling this one as no data. Okay, because I don't think in GDAL calc they insert, we can see if you do GDAL calc, they inserted a no data. Okay, there are over here, so you can try and see if you put this big number back, you can use it. Okay, it's going to be labeled correctly or not. If not, it's going to use GDAL edit to label correctly. So GDAL calc, pay attention, with the no data is doing something strange. So always open back your image and see if it's doing correctly or not, because it's doing the computation also there. So again, pay attention. And here is the GDAL info that probably is going to telling us that the no data value is this number. But what is happening that also this number has been divided by the computation. So probably it's not anymore, if I do a GDAL info, is not anymore the same value than before. GDAL info. -mm, so it's going to get the number, and if I go and check it, probably is not the one that was over here, because also that one has been, look, is different, 3.399, and here is 3.4, because it's been divided by the same operation. Okay, so pay always attention. There are some example over here where you can use it. Or for example, you can exclude the value that are less than 0 or less than a number. So I think one of these example is the, I think, yeah, where you can exclude, this one, yes, where you can excluding, how you can excluding some value in the, not doing some in the computation. So always going back and check, open the, in the beginning is a lot of, okay, try. If you don't get a syntax error, then it's a matter to see if your output is what you want, and you open, you see, you get minimum, maximum, and so on, because you get a result, but then it's not what you want. Okay. So GDAL is also GDAL translate and also GDAL warp are very good for changing pixel resolution, and this one is going to be defined by the pixel resolution is going to be defined by this one. Okay, that in this case we know now what is what it is, and this is going to be the extent of my file. Okay, pay attention, super important. GDAL translate, GDAL warp, they use different corner. One is using this and the other one is using this. So it's always, I don't ask, every time you have to think which one, X min, X max, but if you think carefully, they are slightly different, and will point to you GDAL translate, GDAL translate, and GDAL warp. Okay, so these one are the one that are different. These, so this one X min, X min, epsilon min, Y min, and this is X min, where it is, this one, upper left X and Y. So they are different how they're working, but it's the same concept. So always pay attention. Okay, so so try to we are close to the end. I didn't finish, but we can try to keep going by yourself, and we will review this part next time. Okay, we will go through next time, but this is something really important, the GDAL allocation info to get the pixel value. So try to do by yourself and see how to work with this data in a proper way, and also use the manual to see and understand the command, and start to use it also with your data set. And in particular, you can go back to the today class, let's say to the syllabus, and I've already insert over here. I have already insert the the compulsory assignment is really this: get familiar with all the GDAL command and start to use it on your data set. Okay, cropping, mosaicing, merging, and so on. So start to use it, and then you can use it, and this is how you are going to build your scripting procedure for your final work. Okay, so then there is another suggest assignment that is dealing between a use of GDAL calc for solving an operation that, if you don't do properly, is going to be wrong the result. So this is what you are going to see. But if you do something different, means that you are hitting the precision, the computational precision that is there. So you need to fill it up, all these GDAL calc correctly. Okay, so that's it. Yeah, this is all for today. And